Okay, well, welcome back. We're still in 5.3 slope-intercept form. Okay, so as I said, we're going to start working on graphing these. So we're going to start by taking 2 points and writing them into an equation. What is the equation of slope-intercept form? Represents the line that passes through the 2 points. So now we have 2 points, and what we want to know is what is the actual equation of this. So we have y equals mx plus b. Okay, well, the first thing we want to do is between those 2 points we can figure out through m as y2 minus y1 over x2 minus x1. We can figure out what our slope is. So we're going to go ahead and do that. Now we're going to use negative 8 minus 1 over 5 minus 2. And we find out relatively quickly, we got negative 9 over 3, which gives us, as we go through, 3 goes in the 3 once, 3 goes in the 9 3 times. So our slope is a negative 3. So what we can do now is write in y equals negative 3x plus b. Now what we need to figure out is what is our y-intercept. Well, they gave us a point up here. That's a point on our graph. So we have a y, we have an x, and we have one variable left. So what we can do is we can plug in our 1, which is from this point, and then we can just plug in our x, which is 2 from that point, and now we just have to solve for b, which means we get negative 6 plus b equals 1. We're going to add 6 to both sides. As we add 6 to both sides, we get 7 equals b. So now we can come back up here and say, alright, this was y equals a negative 3x plus 7, and there's our equation. So again, recap, we found our slope through 5.1, okay, and then we just plugged the slope in and plugged in one of these points up here. Pick the easiest one, okay. We plug those in and solve for b, and then there's our slope-intercept form. Okay, so there's another example, got it, number 4. I want you to go ahead and do it. We'll check that tomorrow. Okay, so problem number 5, how do I graph these? Okay, well, we've been graphing lines by plug and chug, making an XY table. Well, with lines, they follow a pattern. We have a slope and a y-intercept, so we don't have to do a table. So what we're actually going to do here is we're going to first plot our y-intercept. It says negative 1. So I'm going to go down here and plot a point at negative 1. Now our slope says we're going to rise to run 1. So what I can do is from that point, I'm going to go 1, 2 over 1. Okay, so a real quick recap. What we did was plot negative 1, which was our y-intercept. So we start from the origin, go down 1. There's our first point. And now we just go rise 2, because that was our slope. Slope was 2, run 1. And we do it again. Rise 2, run 1. Okay, I require three points in this section of the notes. So you need to plot 3 points, and then you get your line. And this line goes on forever, so make sure that when you get done with it, you put your arrows. Don't just connect the 3 points and that's it. Go all the way through and draw those arrows on the end. Okay, that represents it goes on forever. Okay, so here's another example. Now keep in mind, y-intercept and your slope, make sure you're going the right direction. Okay, when you get done, go back and see if you can figure out what the equation would have been. That way it should match up with what you got. If it doesn't, you did it wrong. Okay, well, let's look at modeling now. So now we talked about graphing, let's look at modeling. One of the problems that we have here is water pressure can be measured in atmospheres, which is ATM. Use the information in the diagram to write an equation that models the pressure Y at a depth of X meters. Okay, so what you need to do is you probably need your book at this point, and on page 309 there's a little story problem there. Okay, and so basically what this says is there's a diver, and it says the pressure increases by 0.1 atm / meters, okay, per meters. Okay, at 0 meters the pressure is at 1 atm. So at 0 meters we're at 1 ATM. And then it says that it increases by 0.1 ATM per meter. So we want to write and graph a function based off of this. So the question becomes, well, what is our equation going to be? So we have y equals mx plus b. Again, we're talking linear lines. Okay. Well, what do you think 0.1 ATM per meter represents? Well, it sounds a lot like a rate, and since we said rate of change is the same thing as a slope, it sounds like they gave us our slope. So our slope is 0.1. So I can go in here and say 0.1x plus b is equal to y. Now we want to figure out what our y-intercept is. Now you got to be real careful on this because they actually did give us this information. Right here, if we were to plug in 0 for x, which is what meters is representing our x, we plug in 0. 0.1 times 0 is 0. 0 plus b is b. So right now we have b equals, and they said it's going to equal 1. Okay, that's what our y would have been. So we have 1 equals b. So anytime they give us 0 as the input, that is actually our y-intercept. And if you think about it, if I draw this xy axis, any point that crosses right on this line, they share the same x coordinate. Every x coordinate here is 0 because we didn't move anywhere left and right. We're just here, 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 or here. Okay, so they actually gave us that. So that means we have y equals 0.1x plus 1. That's our y-intercept. So there's our equation. So now all we have to do is now model this in a graph. So when we go to graph this, we're going to put up a Cartesian plane. Okay, you'll have graph paper for this. And we're going to say, all right, we have our y-axis, our x-axis. In this case, our x-axis is the meters depth. And then here is our ATM. And as we go through, we say, all right, well, at 0, we're at 1. Okay, so at 0, we're at 1. And then we're going to increase. So let's say that we went 10 meters deep. We're going to plug in 10. Okay, well, 10 times 0.1, and you'll see why I picked 10. We get 1. So 1 plus 1, we get 2. So this whole time it's y equals. So the reason why I picked 10 was because that was going to move my decimal, give me a whole number. I don't really want to work with fractions. So this one, you may not really want to work with rise over run that much because it's going to be kind of difficult to graph. So I know I'm up at 2 now. Now if I go again, I say 20, and you do the same thing as you go through, you're going to increase. Okay, if I use 100, that's going to be 10 plus 1, and then you're going to be up at 11. Okay, so you pick 3 points here. If we say 20 just to finish this off, we would have y equals 0.1 times 20 plus 1. Well, that's going to give us 0.1 times 20 is going to be 20 with 1 decimal place, giving us 2 plus 1, which gives us 3. So we're right here. Okay, and as we get 3 points, that's good enough. We draw the line. Now notice that I didn't go the other direction because you can't go at a negative depth of meters. So we're going to just have a positive side of this. Okay, so we do have to label ATM, we do have to label meters here, and then we label our points. Since I'm counting by tens this way, which is fine, and ones this way, that's fine as well. We have to label that. Okay, there's a graph on page 309, you can see that a little more clearly. Okay, so that's it for today. We'll really dive into modeling story problems, so we're going to have to learn to work with those. Okay, we'll see you tomorrow.